right, welcome to Unit 6.6, the quadratic formula and nature of the roots. So as I said in the last lesson at the very end, when you were doing these, trying to solve a quadratic equation by completing the square, it can be sometimes a very daunting task. And so we have another tool for our tool belt to be able to solve a quadratic equation. So, because factoring doesn't always work, we talked about that before. Factoring doesn't always work, but completing the square does always work. Though there's a formula that's been developed to solve any quadratic equation that is in standard form. So once you get it into standard form, ax squared plus bx plus c equals 0, instead of going through the process of completing the square every single time, there's a formula that's been developed that does that whole process for you all at once. So what I'm going to do right now is I'm going to develop that formula so you can see where it comes from. I will never ask you to reproduce it. I don't think you'll ever be asked to reproduce it. You can watch this part of the video. You could fast forward through this part of the video, whatever you want to do. But I'm just going to show you how it works. So if you recall, completing the square, you take the first two terms and you factor the a out of the first two terms. So that means I'm going to have an a and then x squared plus, now factoring basically means dividing, so then that's going to be b over a x plus c equals 0. Then you have to take that x term, the linear term that's left inside the bracket, you have to divide it by 2 and then you square it. So we're going to take b over a, divide it by 2, and then square it. So that basically is b over 2a all squared, which turns out to be b squared over 4a squared. So I'm going to take x squared plus b over ax. I'm going to add b squared over 4a squared, and then I'm going to subtract b squared over 4a squared plus c equals 0. All right, so now what we want to do is these first three terms, they make the binomial squared. And remember, so if this said something like 5x squared plus, let's say 12x plus 7 equals 0. You'd take the 5 out, and then that would become 12 over 5x. And then you would take the 12 over 5, divide it by 2, and then square it. So that would be 12 over 10 squared, which would end up being 144 over 100. Yes, that can be simplified, but I'm not worried about that at this point. So then you would add the 144 over 100 and subtract 144 over 100. And then plus 7 equals 0. So back here we have now this part here, these three terms here, they are a binomial squared, and that binomial would be x plus b over a squared. Sorry, b over 2a. b over 2a. It's always half of this term here. So in this case over here, it would be 5x plus 12 over 10 squared, which I know is 6 over 5. And then you would multiply the a through that to this last term that gets that gets subtracted. So these three terms have been taken care of here with that binomial squared. Now the a needs to be multiplied by the b squared over 4a squared. So one of these a's, that a will cancel out one of these a's. And so that's going to become minus b squared over 4a plus c equals 0. So now what we want to do is we want to bring these two terms here over to the other side. And then we'll we'll do that first. Okay, so, and then combine them, get them as a common denominator. So a x plus b over 2a squared equals, we're going to have that minus b squared over 4a is going to become a plus b squared over 4a. And that plus c is going to become a minus c. And then we need to find a common denominator. And so the c has a denominator of 1 right now. This has a denominator of 4a, so that means the common denominator is going to be 4a. So it's going to be b squared over 4a minus, the 1 becomes a 4a because it gets multiplied by 4a, which means I've got to multiply the numerator by 4a, so that becomes a 4ac. So then that gives us ax plus b over 2a squared equals b squared minus 4ac. Oh, this should be an a squared. Sorry. Oh no, that's an a. That one a got canceled. All right, and that's over 4a. And now what we want to do is we want to divide both sides by a. So then that gives us an x plus b over 2a all squared equals b squared minus 4ac all over 4a squared. Because taking b squared minus 4ac all over 4a and dividing it by a is the same thing as multiplying it by 1 over a. And so you get a 4a squared. Now what we want to do is we want to square root this. And so it would be like if we had x minus 3 squared equals, I don't know, 15. So remember what we were doing in the last lesson, that would become x minus 3 equals plus or minus the square root of 15. So this means that x plus b over 2a would equal plus or minus the square root of b squared minus 4ac all over 4a squared. Well, I don't know what the square root of b squared minus 4ac is, but I do know that the square root of 4a squared is going to be 2a, because the square root of 4 is 2 and the square root of a squared is a. So this becomes x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Now what I'm going to do, I'm running out of room, but I'll do it over here. So now I want to bring this b over 2a over to the other side. So that's going to be x equals minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Which means we have, when we put these two together, because they have the same denominator, we can put the numerators together and it's going to become minus b plus or minus the square root of b squared minus 4ac. So the b squared minus 4ac is all underneath the square root sign. And then the whole thing is over 2a. And this, ladies and gentlemen, is what we call the quadratic formula. Ask anybody in academic math, grade 11, grade 12, what the quadratic formula is, and they will be able to recite it from memory. And you want to be able to recite it from memory as well. And I'm telling you, the only way you can do this is you say it over and over and over again in your head until it's not going to leave your head. So you can either say minus b or you can say opposite b. I sometimes say opposite b to remind me that it's the opposite sign of whatever the b is in ax squared plus bx plus c. So opposite b plus or minus the square root of b squared minus 4ac all over 2a. Read it, say it, try and say it without looking at it, but try and memorize this formula, because you will need to know it and have it memorized next year. So opposite b plus or minus the square root of b squared minus 4ac all over 2a. You could Google the quadratic formula, and you could probably Google the quadratic formula memory aids something. There's little songs out there of how to memorize it. And whatever it takes for you to memorize that thing by the time you take grade 11 math, that would be awesome. Okay, so quadratic formula, and the b, a, and c all come from this original equation when everything is on one side of the equation and the whole thing equals 0. So let's just see this thing in action. We've got 4 questions here. So for this first question, it says solve each of the following using the quadratic formula. So in this question, a equals -5, b equals 7, c equals 4. So x equals opposite b, which actually I'm going to write it down, minus b plus or minus the square root of b squared minus 4ac all over 2a. And I say all over, not just over, because I see often students will only put the square root part over the 2a, but it's the whole thing that goes over the 2a. So what we get, opposite b, b is 7, so this is going to be -7, plus or minus the square root, 7 squared minus 4 times a, which is -5, times c, which is 4, all over 2 times a, which is -5. Now then you calculate what's underneath the square root sign. So 7 squared is 49, minus 4 times -5 times 4. So that's going to end up being plus, because a negative times a negative is a positive. So that's going to end up being 49. You can use your calculator to do that, but that's going to end up being 49 plus 80. Because 4 times 5 is 20, times 4 is 80. So that's going to become -7 plus or minus the square root of 49 plus 80 is 129, all over -10. So you have your 2 answers. You've got x equals -7 plus root 129 over -10, and you have x equals -7 minus root 129 over -10. So when I get my calculator out, I'm doing -7 plus the square root of 129, and I hit equals to calculate that because I need that whole answer, and then I divide that by -10, and I get an answer of -0.44 when I round to 2 decimal places. If you don't get that answer, keep trying until you do. For the next one, I'm doing -7 minus root 129, and I hit equals. That gives me -18.357816669. I divide that by -10, and that gives me +1.84. And those are my 2 answers. And that's all there is to it. The hardest part of this is memorizing the formula. Using the formula is pretty easy. So for part B, you cannot use the quadratic formula unless the whole thing equals 0. So that 25 has got to come over to the other side. So we got 4x squared minus 20x plus 25 equals 0. So A equals 4, B equals -20, C equals +25. It doesn't equal -25 like it is in the original question. So x equals, we already have it written over here, I'm not going to write it down again. Opposite b, b is -20, so opposite b is +20, plus or minus the square root of -20 squared minus 4 times 4 times 25, all over 2a, which is 2 times 4. So that's 20 plus or minus the square root. Negative 20 squared is positive 400. The answer that you get from this beginning part, this b squared part, is always positive, because you square a negative, you get a positive, you square a positive, you get a positive. So that's technically 400, because 20 squared is 400, minus 4 times 4 times 25. That equals the square root of 0 over 8. So x equals 20 plus 0 over 8, and x equals 20 minus 0 over 8. So basically, x just equals 20 over 8. So 20 divided by 8 is 2.5. So both the roots, or both of the solutions that you get in this case, are the same number, which means there's actually only one solution. So for the related quadratic, for the related parabola, there's only one time it's going to hit or cross the x-axis. So what does that mean? I want you to think about it, because I'm not going to tell you the answer to that. If it's only going to hit it once, what does that mean that that parabola looks like? All right, next one. Again, we have to expand and simplify. Everything has to be over on one side. So the left-hand side is basically 2 times x minus 3 times x minus 3 minus 4. The right-hand side is 3x plus 3 when you expand that out. X minus 3 times x minus 3 is x squared minus, this is going to be a minus 3x. That's going to be another minus 3x, so that's a minus 6x. And negative 3 times negative 3 is plus 9. Expand out this bracket, that gives you 2x squared minus 12x plus 18 minus 4 equals 3x plus 3. And now move everything over to one side of the equal sign and simplify. So that's going to be a 12x squared. We got a minus 12x and then a minus 3x when that comes over here. We got a plus 18 and a minus 4, and then we've got a minus 3 as well. So that becomes 2x squared minus 12 minus 3 is minus 15x. 18 minus 4 minus 3 is 11. So A equals 2, B equals negative 15, C equals positive 11. So x equals positive B, opposite B, which is positive 15, plus or minus the square root of b squared. I'm just going to write it. Negative 15 squared is 225. Minus 4 times 2 times 11. All over 2a is 2 times 2. So it's 15 plus or minus the square root on my calculator. 225 minus 4 times 2 times 11 equals 137. All over 4. So x is 15 plus root 137 all over 4. So 15 plus root 137 equals, divided by 4 equals 6.68. Or x equals 15 minus root 137 all over 4. 15 minus the square root of 137 equals 3.295 divided by 4 equals 0.82. So there's your two answers. Now for the last one, A equals 3, B equals 4, C equals 6. So x equals opposite b. So negative 4 plus or minus the square root of b squared. 4 squared is 16. Minus 4 times 3 times 6. All over 2a. 2 times 3. So negative 4 plus or minus the square root. 16 minus 4 times 3 times 6 equals negative 56 over 6. What's going to happen? Think about it. Hopefully you said you can't do that. You cannot take the square root of a negative. That does not mean we did anything wrong. That means that there is no solution. Again, this is a parabola. It opens up. I'm going to guess that the vertex is above the x-axis because it's telling me this is not crossing the x-axis. There's no solution. There is no x-intercept. So it opens up, which means that the parabola must be the vertex. I don't know what the vertex is, but I'm going to say that just because this stuff underneath the square root sign was negative, it's going to have to be above the x-axis for this parabola to never cross the, we know the y-intercept is 6. I don't know what side of the y-axis this parabola is on. I really don't know what it looks like at all. You can get Desmos out and take a look and see what it looks like, and it probably is exactly what's going to happen. It's above it. The vertex is above the x-axis. There's no solution here. Okay, so that is the basics behind the quadratic formula. Really, really easy to use. It's just a matter of substituting numbers into a formula. It's no different than, say, using the formula for finding the surface area of a, I don't know, a cylinder or something. You just substitute numbers into a formula and you calculate. And make sure you use order of operations properly, okay? Make sure you remember that when you're squaring that b, that answer is always going to be a positive number. Negative 220 squared is positive 400. Negative 15 squared is positive 225. Okay, I'm going to stop this video here, and the next part of it is talking about what kind of roots you can get. We've kind of seen a little bit of what can happen, just to give a little bit of a precursor to what's going on. In this question, we have two different roots. They are real numbers. They are irrational numbers because the square root of 129 is an irrational number, but that's still a real number. This one here, you can see that there's actually only one root, and it is 2.5. Or sometimes we say that that is two equal roots. Sometimes. This question here, we have two different roots, two roots. Here we had two roots. And this one, we have 0, and I'm going to throw this word real roots, because when you get to a point, there actually is a whole new number system where you can take the square root of a negative. You have only ever learned about the real number system. That's the only one you really know about. There's another number system beyond that. You know how there's the whole numbers, and then like originally there's like the natural numbers, and then there's the whole numbers, and then there's your integers, and then there's your rational numbers. Those are all your fractions and everything. And then there's your irrational numbers. Those are all those numbers that can't be expressed as a fraction. And then all of that put together is your real numbers. Well, we can go even further than that. And there's another number system, and it's called the complex number system. And it allows you, this number system allows you to take the square root of a negative. And what they do in it, and I'm not going to go beyond this, and if anybody's interested in any of this, you can do a little Google search on the complex number system. But it allows you to take the square root of a negative, and it tells you that the whole basis behind the complex number system is that the square root of -1 is equal to I. So I is a whole nother thing in the complex. It's not a variable anymore. It's now a number, and it's called the imaginary number. It's craziness. I'm telling you, it it'll blow your mind when you learn about it. Okay? I'm going to stop again. I'm going to stop there, and I'm going to do the nature of the roots in the next lesson. I kind of cheated here. I got 2 lessons in one. I want to get through this stuff because it's really, really important for grade 11 and grade 12.